So today we are going to start with the equations of integration, which are quite useful in kinematics. We had studied about the equations of differentiations, and just to revise, v is equals to ds upon dt, where s stands for the displacement. To find the velocity, we take the derivative, the first derivative of displacement with respect to time. Similarly, we studied that acceleration is equal to the first derivative of velocity with respect to time. It can also be written as velocity and the first derivative of velocity with respect to displacement, v dv by dx or v dv by ds if we write s as displacement. Similarly, acceleration can also be written as the double differentiation of displacement upon time. Out of this, the first and the second and the third and the differentiation of displacement with respect to time, the four important equations of differentiation we need to keep in mind. Similarly, we're going ahead in equations of integration. We are going to study the same thing, but we will be transferring or transposing few terms. If we have v is equals to ds upon dt, we can keep ds at one side and send dt to the other and take the integration on both the sides. This is what we call as displacement. Displacement is the integration of the velocity of the area under the velocity time graph. Equation, that is acceleration is equals to dv upon dt. Over here we can transfer the terms. We can keep dv on one side and send dt to the other. So we will get integration of dv is equals to integration of a dt. That is the area under the acceleration time graph is velocity. Acceleration is also equal to v dv by dx. So we can write it, get v dv is equal to v dv is equal to ads, and if we integrate both sides we get another equation of integration. Now we need to keep this in mind whenever we are given with whenever we have the xt graph or simply the st graph, that is the displacement time graph, and whenever we are given with the velocity time graph or the acceleration time graph. All these graphs will be explained, but now for a generalization, if we have the acceleration time graph, we integrate and get velocity. If we integrate velocity time graph, we get the displacement. Over here we integrate. Similarly, if we are given with the displacement time graph and we differentiate, we would get velocity time graph, and similarly if we differentiate again, we'll get acceleration. When we have displacement and we differentiate it, we get velocity. We differentiate it again, we get acceleration, and if we integrate acceleration we get velocity, and if we integrate velocity we get displacement.